Hello everyone and welcome. Today I would like to talk about remove duplicates from sorted array. So one tip is that when the array is already sorted, think of using pointers. There are some quick solutions I would like to present here. First, we can use set and sorted function, and this gives us a time complexity of O n of n since we use a sort function, but this fails to leverage the fact that the array is already sorted. The second possibility is to use a hash map instead, an older dictionary. But this older dictionary allocates extra space. So the space complexity here is On. So can we do time On and space O1 instead? Improve on both time and space complexities. And here's more detail about this question. The question provides you a nonce array sorted in non-decreasing order or ascending order, asks you to find the unique items and to place those unique items in the first k slots of nonce array, and asks you do not allocate extra space. For another array, you must do this by modifying the input array in place with O1 extra memory. One quick possibility is to use pop. So we use the I to track the unique item in the nums array, and whenever we encounter duplicates, we pop that item and we move on if it's a unique item. But this one, as you can see, the pop has a time complexity of k if we pop at a k item. So the overall time complexity between On and On squared is not as efficient as we wanted, although the space complexity is O1. Here's another possibility. Use two pointers. So pointer I and pointer J. So pointer I is to record a unique item found so far. Pointer I is initialized to be 0, point to the first number here, and it's a unique number, and pointer J then initialized to be 1, is to traverse through the nums array and to detect the next unique item. So you can see here, if finds the number 0 here is a duplicate item, so J will continue to traverse to the next item to see if it's duplicated or is a unique item. So if nums J is larger than nums I, then we have found the next unique item, given that the nums array is in non-decreasing order. And when that happens, we'll move I up one step and write the unique item into nums I. So nums I is always trailing behind J and record the currently unique item found so far. Importantly, this code here has time complexity On and space complexity O1. So it certainly is better than the set and sorted method as well as the hash map, which allocates extra space. With the background introduced, now let's write the code. So first of all, we initialize I to be 0, and we're going to traverse J from 1 to the nums array, okay? And we quickly want to know if I and J are different and in this non-decreasing order. If that happens, we move I one step up and have the I record that unique item, the next unique item. Otherwise, J will keep traversing to the next item. And finally, we simply return I plus 1, given that it's a 0 index. So it's the same as our solution in the previous slide. So let's test this code to see how it works. We submit and done. It's pretty good in the time and space complexity here. Okay, so we already analyzed the time and the space complexity. So just to write it for competitiveness. Okay, so that's all for this video. I hope you find this video to be useful. Please feel free to subscribe for more videos. And I hope to see you next time soon. Goodbye.